All right, let's talk bulk Ethernet cabling. This is the video if you want to know what kind of cabling to buy for a residential home install. All right, to be clear, when we're talking about Ethernet cabling, we're talking about twisted pair wiring. 4 twisted pair inside of a jacket, that sort of Ethernet wiring. I know people out there will be like, well, fiber is Ethernet too. Yes, fiber is Ethernet, but when people are talking about Ethernet cabling, nobody ever means fiber. Everybody always means the standard sort of Ethernet cabling that everybody's familiar with. Fun fact while we're here, we might as well go a little bit into the history. This twisted pair here that you see here is just, one of the pairs that go into modern Ethernet cabling, but this same twisted pair setup was invented by Alexander Graham Bell for the phone originally. In fact, an Ethernet cable is literally 4 phone wires put together. They're stranded a little bit differently to cut down on crosstalk, but it's just 4 phone wires all in the same jacketing. In fact, after computers got so popular in the 90s and they started building data centers, the economies of scale on Cat5 cabling became so large that all home builders more or less started to buy Cat5 instead of normal home phone cabling, and then they just used Cat5 to wire phone systems in homes. So I mean, you can actually carry 4 phone signals over one of these wires. Though typically they run them in daisy chains, so unfortunately you typically can't reuse them for a data purpose later down the line. It just depends. If they run it just the one line to somewhere, then you can actually retrofit it for Ethernet. And I'll have a video on that process if your home is set up like that. All right, so on to the main event. This is the cross section of an Ethernet cable. The Cat6 in this case, you can see the cross member, which I'll show you live in a little bit here. But so here we go. And the things we have to worry about when we're buying Ethernet cabling is, first off, the jacket itself on the outside. There's basically 3 types of cabling. You can find unrated cabling out there on the internet. My suggestion is just skip this entirely. You're allowed to use it if you put it in conduit and then there's no point. Just use riser cabling. It'll end up cheaper if you're putting it in the walls. And this is typically, 90% of the cabling you'll see in any sort of residential install. You're allowed to go between floors with riser cabling. That's why it's called riser cabling. And so long as you've got it sealed behind a wall, that'll be just fine. Plenum grade cabling is actually a lot more expensive, but it's got a jacket on it it won't burst into toxic fumes when set on fire. So if you've got this cabling long term in a space that shares the same space as humans, you've got a wire tray in a maybe an industrial conversion or something, so it's just out and sharing the same space as people, then you need to pony up and actually use the plenum grade stuff to pass code. All right, the next thing you have to worry about is the wire composition. Pure copper versus copper clad aluminum is the first worry. Just like if you watch the coax video and you notice that you could run into copper clad aluminum coax that is a lot cheaper, you can run into the same thing with Ethernet cabling. Only with Ethernet cabling, if you cheap out, it's really going to notice. Coax is a little bit more forgiving because it's kind of a more primitive technology, but Ethernet, it will give you big trouble, especially if you're trying to run power over Ethernet at some point down the road. And there are a lot of things that run on power over Ethernet. If you put security cameras in, for instance, power over Ethernet right away. So you got to worry about that. Make sure you get pure copper. Don't get tricked. The other thing you need to worry about, and it's not so much a trick, there are basically 2 different types of cabling. There's when these intertwisted pair, they can be solid copper, and that's meant for structured wiring. If you're putting it in the walls and it's not going to move around a lot, then the solid cabling is the better way to go because it conducts better. But patch cables, if you go out to the store and buy an Ethernet cable from an office supply store, and you're like, oh, 15-foot Ethernet cable, that is actually made out of stranded cabling. That way you can flex it around and the wire isn't going to eventually metal fatigue and then snap on you, and then you don't have a connector anymore. If it's stranded, then it's flexible, and that's the way basically all sorts of things are made. Electrical extension cords are made the same way. If you want a cable to be flexible, you use stranded cabling. It doesn't conduct signal as well over distance, so when you've got that's why they make the solid cabling, is because when you've got that option to install it in some place where it's never going to move, then the solid is the better option. So when we're talking about Ethernet cabling to put into your building and wire into the walls, then you want that solid cabling. When you're talking about patch cables, just buy your patch cables anyway. But if you need to run some sort of long custom one for whatever reason, then stranded cabling is the way to go there. And then we kind of touched on this already, but the American wire gauge thickness, you got to worry about that. Some people will try and sell 24, which is thinner than 23, which is the standard, and standard for Cat 6 for sure. I have seen 22 wire gauge Cat 5 made specifically for power over Ethernet applications. Like if you're running just a bunch of cameras and it's just going to be a bunch of cameras, then you can get thicker wire gauge stuff that there'll be less loss to heat because it's going through a larger cable. It's just more expensive because you're using more copper. All right, so the last thing we need to talk about is the category rating of cables. This is the bit that people tend to get preoccupied over, kind of unnecessarily sometimes. And regarding all of the category types of cabling, the manufacturers will usually submit a roll or two to Underwriters Lab or some other third-party verification to verify these things' performance characteristics. That's reputable sources. Obviously, there are fly-by-night brands out there that will just basically lie and say, "Oh yes, we qualify for that," and it's just not true. So quality is a little bit harder to determine. With the characteristics of the cabling that we showed you earlier in this video, you should be in a good position to make sure you get some quality cabling. But again, I mean, you can't defend against out and out lies. So make sure you're getting cabling from a reputable source, from a reputable vendor that people know and trust. All right, so Cat 3 cabling is a retired cabling at this point. I'm only bringing it up simply because, a little bit of trivia, but you might actually run into it in a wall in a retro job. So depending on what it is, you may actually find a use for it, maybe in some sort of edge case. But anyway, it's 3 pairs of wire. They're all unshielded. It's 24 gauge wiring. It's basically what you would wire for like telephone at the end of the telephone wiring era before they started using Cat 5 for everything. It's only rated at 16 megahertz. You use in a real noisy environment, I guess. But when you see like a 10100 switch versus a gigabyte switch, Cat 3 is the bit that's the 10 of that 10100. And with some non-standard wiring, you can typically get 100 megabytes a second to work off of Cat 3, maybe depending on the equipment you've got. Broadcom has a protocol that deals with this. But anyway, it's more of a trivia thing than anything else. It's not really a good cabling. All right, and Cat 5 cabling is the first like real retro cabling that's kind of useful still. Typically, if it's a really short run, you can get a gigabyte off of it. So, I mean, it's potentially worth a use case. I have rewired a number of kitchen phone locations on a wall to be a built-in Ethernet access point, and with a couple Ethernet cable ports on the bottom of it. If the house is wired where the Cat 5 cabling is going, a fairly short distance and directly down to wherever the phone wires are wired into the house. So it's not daisy chained to anything. It's just all one straight shot. Then it's got a potential still valid use case. You probably get a gigabyte a second on it. I've gotten that many a time. The Cat 5 specification only guarantees 100 megabytes a second though. So on that 10100 switch, 100 megabytes a second is like the Cat 5 limit there. All right, and then Cat 5e is a revision of the Cat 5 specification. where they tightened it up a little bit so they could guarantee that gigabyte connection over short distances versus like anything goes free for all, where the cable quality was wildly different. This was kind of the first specification where they like really were like, all right, we need to like look at this and figure out how we need to get this down so everything is kind of uniform and we don't have like crazy wild variance in the cables itself. So it specified like tighter cable twisting, and it upped the frequency rating. Well, at Cat 5 it was still 100 megahertz, but occasionally you'd find Cat 5e cables that were built to 250 megahertz, just a little bit higher quality. It just depends on the manufacturer. Again, on unshielded cable still. It's just. If you find this, so much the better. It's just the nicer version of Cat 5 that still exists and like still gets made in factories. So Cat 6 is your bread and butter new cabling. You'll notice here it's still unshielded. It's still fairly low frequency range by specification. You'll see 250 megahertz. That's not a whole lot in comparison, but you'll find Cat 6 cabling out there that's sold as Cat 6 that actually is rated to much higher frequency ratings. They're ultimately the only thing you need a Ethernet cable to do is get to a certain frequency rating and keep crosstalk and other interference from the outside up through that frequency range. So the more shielding you put on something, the better it's going to perform in that regard. It's just a question of how much needs to be there in order to meet a certain specification. And there are ways to, without putting actual a shielding system on it that has ground wires and all the complication. There are ways to reduce crosstalk without going through all that craziness. So Cat 6, Cat 6 and Cat 6A have this vague range between each other where, so long as you're not going for the Cat 6A that's shielded, it kind of all blends together a little bit. But the Cat 6 specification guarantees a gigabyte all the way out to the maximum run of 100 meters. And when you're under 55 meters, you're probably going to get the 10 gigabytes a second. So this makes Cat 6 the new standard. Like, this is what most people put in the wall. It gives you a little bit of future proofing. The Cat 6A, like I was just saying, there is a version that is a shielded Cat 6A, and that's like the absolute highest version of the specification. But it's a complicated install in comparison to all the unshielded versions. You can meet the Cat 6A frequency rating without going to a shielded version, and that guarantees you the 10 gigabytes out to the maximum distance. So, I mean, if you're worried about servicing 10 gigabytes, you may look at Cat 6A. Just don't look at a shielded version, because if you don't go through the proper steps and get the proper things so you can ground it all the way through the path, then if you get a shielded cabling, it actually will perform worse than the unshielded cabling, possibly because all the shielding and foil in there, if it's not grounded, rather than blocking out everything, it may induce noise into the system. So it could be potentially worse than an unshielded thing in its place. So if you're looking at trying to meet the spec, try and find a really high quality Cat 6 cable, and that way you don't have to worry about shielding it per se, and you're still going to get your 10 gigabyte, which is like the limit of what anybody would ever want for service. Like, there are no possible conceivable use cases that, like, 10 gigabytes a second at network speed is a huge amount of data. Even like a VR playroom or something would probably clock in well under that, especially if you have to like exchange data with outside. It would be hard to come up with anything that would even get close to that sort of limit. So with a Cat 6A sort of rating, then I mean, you're pretty much good to go. You don't necessarily want to step beyond this into the gulf of actually shielding all of your stuff unless you've got a good reason to. Like you run plasma torches in your workshop or something. Like something crazy where, oh, I make a whole bunch of electromagnetic noise with my hobby. Like in that case, okay, maybe think about it, but I would hesitate as a normal person to bridge that gap. It gets a lot more expensive and a lot more complicated, and potentially your performance degrades if you do it wrong. So it's a bridge that is highly worth considering before crossing. All right, but you're the sort of person who watches a YouTube video about what bulk cabling to buy, so presumably you want a little bit better explanation than me just telling you, hey, just stop at some really nice Cat 6 slash Cat 6A that's unshielded. If you'd like to go a little bit further, I guess we'll do that. So here we go. The unshielded twisted pair versus shielded. Unshielded twisted pair doesn't need to be grounded, and that's basically the giant advantage to it. It provides for a foolproof install because it doesn't need to be grounded. So in that regard, it's the popular cabling everybody puts in. It's very easy to train people to do. It's harder to screw up, and if you screw up a part of it, it doesn't like ridiculously affect the performance of it. Whereas a shielded cable absolutely needs to be grounded along the whole path. So you need metal connectors and metal frames and grounding wires and grounding blocks, and you need to have the whole thing set up to do that. All the cabling needs to have specialized ends and such. It's a more expensive way to go. All the connectors are more expensive. The cabling's more expensive. And because you have to worry about the grounding, the install difficulty is much, much higher. And you've got the potential of, if you do it wrong, like if it's not all the way grounded, then all that extra metal in the cabling can potentially induce noise from outside because it's not grounded. So it's like a giant antenna wrapping around your cabling. So unless it's grounded, it doesn't actually provide shielding. It does the opposite and makes everything worse. So people who just buy like a roll of Cat 6 or a Cat 7 or Cat 8 and put it in like a normal cat cabling because that's the instructions they saw online, they're probably doing themselves a disservice, and we're better off just buying normal Cat 6. But if you want to go the shielded route, you just be aware it's a different process with different tools, different equipment, and you need to ground things, and it requires a little bit more planning. It is more expensive to the point where you may just question, hey, why not just put in some Smurf tube so you can pull stuff later, or just go with a fiber thing on the backbones where you absolutely want this sort of performance. It's a valid question because the cabling cost gets way, way up here once you go shielded, because you're putting in foil and you're wrapping every individual thing. The cabling gets thicker and more expensive. You're just making a lot more material. It's a more complicated process, and they don't make a whole lot of it because most people are using unshielded cabling, so it doesn't benefit from the same economies of scale. It's like 3 times the price, roughly. I mean, it's not insignificant, so you want to think about that before you go forward. All right, so on the gulf of the other side of this cabling is the Cat 7 cabling. Though this is kind of like kind of a pointless category at this point. It took them so long to set it up, and the performance isn't that much different from Cat 6A, and for the longest time it was almost kind of like a scam thing. People were like, should I get Cat 7 cable? And you're like, it's not even a certification yet. People are just selling it like that. So it's basically got all the problems of the next category up, Cat 8. It's very expensive, almost as expensive as Cat 8. It's just certified to a lower frequency, and it still uses the 23 American wire gauge thickness of cabling, whereas the Cat 8 uses slightly thicker cabling. It's if you're already going through the trouble of shielding the cabling and you're going to pay the expense of the connectors and do all this stuff, it's not a great idea. But like, if you're going to do it, I suggest just skipping right over Cat 7 and going to Cat 8. Cat 8, I mean, like I said, it's got the thicker conductor, so that's nice if you're doing power over Ethernet stuff. It's rated for much higher speeds that already exist in the wild. I mean, you have to use special connectors and special equipment, and you're going into like SPF plus ports and QSPF plus ports and like all sorts of specialized connectors that you won't see on residential stuff. But technically speaking, the cabling can handle it, at least out to the new spec limit of 30 meters. So about 93 feet is the maximum run you can get on Cat 8 and expect to get like the 20 or 40 gigabytes a second performance. And then there are, like, if you're using small little cables that are under 15 meters or whatever, there are specialized things that get much higher performance, like 100 gigabytes over copper. Like, but that's like in the lab stuff. It's just like it shows there's a lot more headroom in terms of the Cat 8 cabling, so there is a lot more bandwidth there. But I mean, we're talking like 20 or 40 gigabytes a second. Like, there is nothing in your house that you're going to use that for. Like, I mean, if you plug in like a voice assistant with this, and like you're doing power over Ethernet, like okay. It's, first off, it's not going to come with a 10 gigabyte port or a 20 gigabyte port and a voice assistant. It's just going to be a gigabyte port. So you'll only negotiate at a gigabyte. And like it'll get power, okay, great, but like, I mean, even at a gigabyte, it's not going to use anything close to that. Audio just doesn't. A video camera, like just a really high definition video camera streaming all the time, that's about like the worst thing you could do. And like, even if you were doing like just like a specialized camera, if you went out and bought like a camera that they use to shoot TV and like movie films, and tried to like run what it streams out to its memory cards over the network, I mean, you might get to 10 gigabytes a second. You may get a little bit over that, but like, I mean, that's like crazy overkill. You don't need that for security cameras. It's just like not worth it. And even if we are talking like, well, okay, way down the line when there are things that we can't even think about today, there's no scenario where like this Cat 8 cabling is not going to use specialized connectors. It's not going to come down to an RJ45. It's always going to have to be something else. So in order to get that performance, you can terminate with an RJ45 so long as it's shielded and all that stuff, and get the whatever. But if you're going for the really high end specialized performance out of it, you're stuck with specialized connectors, and then that's probably going into the same modular ports that you can put fiber stuff into. So at that point, you just have to think, well, why don't I just get some fiber and put that in here and put media converters on either end, or use that for your backbone between stuff where you think you're going to actually need the bandwidth, or just put in like non-metallic conduit so you can pull whatever you want later. Cat 8 cable, I mean, you can do it if you want. Just know it has to be shielded, and you're going to pay a lot of money for not a whole lot more advantage. Like, practically speaking, I would think it's just not worth it over going with some really nice Cat 6/Cat 6A. Just doing it unshielded and leaving it at that, and in the places where you're worried about it, just putting some conduit in so you can pull stuff later or do what you need to do. It doesn't make a whole lot of sense to run this, but it does exist, and if you have the money and it's burning a hole in your pocket, you can totally do it. It's just, it doesn't make a lot of sense to do, and most people will tell you so. So just think about it before you do it. It doesn't make a lot of sense. You can, but there's no point. Like office buildings where they've got way more use case than your house will ever be, they look at it and they go, no, this just isn't worth it for us. So really think about it before you put it in the walls of your home. Like, it doesn't make a lot of sense to do. It's harder to handle. You'll need specialized people to do it. I mean, it's just, unless you want to make a project of it yourself and learn it and you like that sort of thing, just don't bother with this. Go with some normal Cat 6. All right, so some specialty cabling. First, we got some shielded wire. Like Cat 7 and Cat 8, this is how this works. You've got your braided shield on the outside of it, foil wraps on each individual pair, and then a drain wire that's connected to both that shield and the foil wraps down the cabling. And that drain wire works like a ground cable does in an electrical system. So you need to get that to ground somehow, and it needs to be on both ends of the cabling all throughout the system from plug to plug, essentially. And both devices have to be engineered correctly with metal plates to take those metal things from the cabling itself. So everything needs to work, otherwise it ends up possibly being worse than not having the shielding at all. But if you look online and you see some stuff, this is the sort of dead giveaway that it's shielded cabling. It'll have a bunch of foil and wrap in there, and it'll have a drain wire for sure. And that, if you want to go down that road, go for it. But this should be more warning signs if you see it, and this is just so you won't be confused. All right, and then next up, we've got stranded wire. As you can see here in the difference, the stranded wire is a lot more flexible. The only reason to buy bulk stranded Ethernet is to cut custom length patch cables. For the most part, you should just be buying them in whatever length you want factory-wise. The only reason to cut a custom one is if you need a male connector in some space if you're like drilling out through a wall or something. So sometimes mounting exterior equipment, that's about the only time I've used it in recent memory. It's just so much easier to go out and buy factory-made patch cables. They're just so much more reliable, and like they can do it far better than you can because it's a specialized machine. And then we've got direct burial wire. Direct burial wire that comes in two main varieties. Mostly it comes with the Icky Pick gel here, which is what I've got shown here. It's basically a hydroscopic gel that like repels water that may enter the cable at some point in there. And typically there's a little plastic wrap layer in there as well. And then the other option is a paper layer in there that repels water, and also when it gets wet, it kind of releases one of these hydroscopic compounds around where it gets wet. So it's kind of like a self-activating if it ever runs into water. And then an extra bonus is this paper is actually extremely hard to tear. You'd have to go at it with a knife or like a sharp shovel or something. It makes it a little bit more robust if you're going to bury it. However, I have to say, if you're going to bury wire, don't bury Ethernet. Just go through the trouble of getting the fiber for that run. It'll just save you so much headache in the long run. And fiber is non-conductive, so exterior lightning strikes, you don't have to worry about it with a fiber run. Whereas Ethernet, you're just opening up a attack surface, so to speak, from lightning. It's not the end of the world, especially if you bury it deep, but copper is always susceptible, so it's better to do the fiber anyway. That way you can upgrade the bandwidth links on either end. But if there's some reason you need to do direct burial Ethernet, this is the kind of cabling you'll run into. And then finally, the last bit we need to worry about here is what's called a messenger wire. And this is just purely structural. All it is to do is it's meant for aerial wire. So if you're hanging wire to go in between two buildings and it's just suspended in the air, a messenger wire makes it so the cabling that you're using to transmit data isn't suspended by its own weight. It's got a rigid member also attached to it in the same way, just suspending it there. So that way the cables don't sag, which is something to be avoided when you can. So if you see something that says it's got a messenger on it, that's going to be a wire connected to keep the cable rigid when you suspend it in the air. The use case for this is rather limited. All right, so this turned into rather a long one, but you should be well on your way to Ethernet cabling shopping mastery now. You should be able to assess the cabling you see online and know what to buy. Again, as always, I'll have a kit put together with all of my recommendations that will try and keep up to date. Even further on down the line, you should be able to come and get relatively up-to-date recommendations. However, hopefully because of this video, you should be able to go shopping as an informed consumer on your own. And I hope you learned enough to do that. See you next time.